Welcome, welcome, welcome. College trigonometry online. Let's do this. So just some things about college trigonometry. We're going to have three sections, uh, three chapters that we do, chapter 9, chapter 10, chapter 11. And you're looking at about three tests and then a cumulative final exam. So that's what you got to look forward to. So module 1 is all about chapter 9, so that's where we're going to start. We're going to be doing section 9.1 in this video. Please know that we are going to rely heavily on your college algebra skills. So you need to make sure that you dust those off and you get those ready, because we're definitely going to be using those college algebra skills in this. We're just going to be using them a lot of like trig style, and you'll see that start to come out through things. So definitely want to have your calculator ready. In the orientation module, I told you how to download this kind of calculator. You definitely want a calculator for this exam, okay? Or not exam, but for this course. We're heavily going to be relying on that, okay? So those are just kind of some tidbits. So let's go ahead and get started with section 9.1. 9.1, I'm going to give you a lot of basics in here. We're not going to quite hit the trig piece yet, but we are going to get there definitely by 9.2. But in here we need to talk about some basics. So this beginning part's going to feel a little bit geometry-ish, because we're going to review angles, because angles are very, very important for us here in trig. Trig uses angles to help us create proportions of sides, which helps us do a lot of solving, either for missing side lengths or for angle measures and things that we can do. So angles are going to be pretty important for us. So let's go ahead and talk about what an angle is. So an angle is formed by rotating a ray, the initial side, around its endpoint, the vertex, to a terminal side. So down here I have an angle. Okay, so the initial side generally is this guy that's right here. The initial side usually lies on the positive side of the x-axis. This little dot right here, that's your vertex, which is usually placed at the origin. And then this long guy right here, this is your terminal side. And when we talk about angles, so you got your initial side here, your vertex, and then your terminal side. And so angles rotate generally counterclockwise. We like our angles to rotate counterclockwise like this. Reason being, because when we rotate counterclockwise, that creates positive angles. A counterclockwise rotation is positive angles. A clockwise rotation is a negative angle. And when we also rotate, the rays should stay the same length. I know I kind of shrink down here, but I want you to see that ray is still there and things like that. So when we rotate, the initial ray and the terminal ray are generally the same length. So again, the initial side, generally on the positive side of the x-axis, vertex is the origin, and then your terminal side lies out here in somewhere on the quadrant, in the quadrants, the four quadrants, 1, 2, 3, and 4, or somewhere on the vertices, or sorry, not vertices, axes. Okay? Counterclockwise is a positive angle. Clockwise is a negative angle. All right. So from there, we can talk about two different types of angles. If you see these angles in here, and then versus these that look like right here. So we have two different types, again, straight from geometry. The kinds of angles that we're dealing with here, well, if you notice that we've got this right angle symbol right there, that's what the little box means, right angle. So angle 1 and angle 2 make up this right angle, and then we got 60 degrees and 30 degrees. Anything special about these? Absolutely. They are what we call complementary angles. Two angles that sum to 90 degrees are called complementary. The angles can touch, like what you see right here. So these are complementary angles that form that right angle right there. They can touch, but they don't have to. Like the 60 degrees out here over on the left and the 30 degrees over here on the right. These two angles are complementary because 60 degrees plus 30 degrees is 90 degrees. Okay? And then hopefully you picked up over here, since I mentioned complementary, you automatically know what these are. Supplementary. Yeah, absolutely. Oh, I didn't know you guys were joining me for this video. Cool. So over here we got supplementary angles, which means that two angles that sum to 180 degrees. So these are special supplementary. If you remember in geometry, we called these linear pairs. So they're a special supplementary because they touch. Complementary doesn't have anything special about it. When they touch, it's just called complementary angles. But these are special. In geometry, we called them a linear pair, which were super important for us in geometry. In trig, they're okay. It just means that these two angles are supplementary because they form that straight line right there, hence linear pair. And then obviously these two angles are supplementary because 110 degrees and 70 degrees give you 180 degrees. So if I add these two angles up, they're definitely supplementary. So in your assignment, they're going to give you some pictures and they're going to want you to solve for x. Or maybe once you find out what x is, they want you to plug back in and tell us the angles. Just read the directions and figure it out. So go ahead, pause the video, give this one a shot. Okay, so hopefully you realize that over here, these are complementary because they have that 90-degree angle right there. So that means since they're complementary, these two angles must add up to 90 degrees. So 6x plus 3x, that gives us 9x equal to 90 degrees. Divide by 9, divide by 9, and you find out that x is equal to 10 degrees. Okay? So that might be one of the answers, or they may want you to plug back in. And that's not that hard. If I take 6 times 10, that's 60 degrees right here. 3 times 10, that's 30 degrees. There are my angles, and that definitely verifies that these things are 90, because 60 plus 30 is 90. Over here, hopefully you saw that, oh, these are supplementary. That's that linear pair that I talked about a moment ago. And since they're supplementary, that means the 4x plus the 6x must equal 180 degrees. So 4x and 6x give us 10x, 180 degrees. Divide by 10, divide by 10, x equals 18 degrees. Okay? And if they want you to plug back in to figure out our angles, this is what you're going to get. 72 degrees right here, 108 degrees right over here, and of course, again, that verifies that yes, these are supplementary. Okay, so you have a little bit of geometry to begin with in some of your problems. Oh, right here, one more geometry type problem. They want to know, given this angle 24 degrees, what is the complement to that? Given this supplementary angle here, or given this angle 24 degrees, what is the supplement angle to that? Go ahead, pause the video, and kick out my answers. Okay, so to be complement, remember that's 90 degrees. So all you really have to do to find the complementary angle, or the complement angle, is just take 90 minus 24, and that gives you 66 degrees. So the complement angle is 66 degrees. To be the supplement angle, all you gotta do is take 180 degrees minus the 24 degrees, and that will give us 156 degrees. And there's the supplement. Because if I take 24 and 66, that means they're complementary because they add to 90. If I take the 24 and the 156, that means they're supplementary because they add to 180. That's all they want. So there's a little bit of geometry for you. Now we're going to start diving into angle measures. So when we're in geometry, we like to work with angle measures two different ways. Right now, we're just going to talk about degrees, minutes, and seconds. So we're adding in the idea of minutes and seconds as in navigational terms. Also, when you talk about longitude and latitude, you could talk about degrees, minute, and minutes, and seconds. So before we start messing around with degrees, minutes, and seconds, I want to know some information. So this is kind of like if you're in college mathematics, I want to know about this unit fraction that exists. So if I had 1 degree, I want to know how many minutes is that? So what do you think? 60! Absolutely. You guys are so good. You're so smart today. So 1 degree is actually 60 minutes. Okay? Or if you have 60 minutes, you have 1 degree. All right, down here, hopefully you know this next one. If I have 1 minute, how many seconds is that? Well, hopefully you're like Mr. Armstrong, duh, it's 60. And I would be like, duh, you're right. All right, then the grand poobah question of them all. If I give you 1 degree, how many seconds is that? And we need this information. Okay? So if you have 1 degree, how many seconds is that? Well, here's what we know. 1 degree is made up of 60 minutes. 1 minute is 60 seconds. So all you have to do is multiply those two together. And hopefully you were thinking 3,600, Mr. Armstrong. And I would be like, yeah, you're absolutely right. 1 degree is made up of 3,600 seconds. Okay? So, let's talk about converting to decimals. So right here, I'm giving you degrees, minutes, and seconds. And I want you to convert this into nothing but a decimal degree value. Okay? So, if I want to convert this into a decimal degree, so no more minutes and seconds, right here, we already know what the whole number is. We know that it's 18. What we're trying to figure out is what is the decimal like after this. So we're going to convert this into a decimal. That's where we have this information. Whoops. That's right here. That's going to help us. Okay? So if I have 9 minutes, remember that this is making up, we want to know how long is 9 minutes in degrees. Well, we know that 1 degree is made up of 60 minutes. So in other words, we want to know what is the proportion or the ratio of 9 to 60. So if I take 9 divided by 60, because there are 60 minutes in 1 degree, and you find out that this is 0.15. And so all I'm going to do to get my final answer up here is I'm going to take this decimal right here. I'm going to put it after the decimal that's up here, because 9 minutes represents 0.15. So 18 degrees, 9 minutes in purely degree form is 18.15 degrees. All you do is you take and you slap that decimal onto the end. Okay? Go ahead, pause the video, and give 74 degrees, 8 minutes, and 14 seconds a try. And go. Okay. So you already know that we have the degrees right here. So 74. Oops. We know that's the whole number. Now we got to figure out the decimal. Well, first off, we already know how to convert minutes into degrees. We're just going to take 8 divided by 60. And when you take 8 divided by 60, you get a long decimal of 0.1333333333. I put all these 3's on there because we have to be accurate in here. Okay? You need to be as accurate as possible. In trig, you're going to be dealing with a lot of answers where they want you to be accurate. They want the real answer. Okay? But also in trig, you're going to be dealing with a lot of moments and situations in your assignment where you'll have to round to. And when you round, you only round at the end. Otherwise, you have what is called rounding error, which could throw you off. So you need to be careful of your rounding skills in this. You need to make sure that you are reading the information that is under the answer box, because it'll tell you if it wants exact answers or if it wants a rounded answer. Read that information very, very carefully. Also, so you know, when it comes to rounding, They're generally your rounding skills are going to have to be to the nearest whole number, to the nearest tenth, to the nearest hundredth, or to the nearest thousandth. So you need to make sure that you know those. And they present that at you at different ways. They might say to the nearest tenth, or it might say to the nearest one decimal, or it might say to the nearest hundredth, which would also be 2 decimals. Okay, so make sure that you read carefully. Rounding is going to be kind of your killer on some of these. Now, let's talk about seconds. This is why I asked you that final question right here. What are the number of seconds in 1 degree? Because we need to figure out how many degrees as a decimal 14 seconds really is. And then all you have to do is take that 14 divided by 3,600. So if we take 14 divided by 3,600, we get 0.0038 all around. Okay? So to get our final answer, what you need to do is you need to add these 2 decimals together, because that's going to make up the entire decimal up here. Because these 2 decimals, this makes up the minute part, this makes up the seconds part, and you got to put them together to get the real decimal. So if I take 0.133333 and put in a lot of 3's in your calculator, plus 0.003888888, put lots of 8's in your calculator, you get the following decimal: 0.137, and then lots and lots of 2's. So, degrees. And then this is where you'll read that fine print below the box. It might say round to the nearest whole, which would be 74 degrees. Round to the nearest tenth, which would be 74.1 degree. Round to the nearest hundredth, which would be 74.14, because the 7 says, hey, 3, go up. Or thousandth, which would be 74.137 degrees. So make sure that you read that fine print below it. It's going to tell you where to round, I promise you. Now, cool thing, let me show you some neat tricks on the calculator. So, since we're talking about degrees, minutes, and seconds, when you're dealing with your calculator, when we deal with trig, there are 2 different types of ways we measure angles. We can measure them in degrees, minutes, and seconds, or we can measure them in radians. We're going to talk about radians soon. We're just not ready for that yet. So right now, if you look right up here in my calculator, I'm in radians. You always need to double check your calculator in trig to know what mode you're in. Okay? So if you can't see this up at the top of your calculator, usually most calculators tell you, go into mode, and then right here, the 4th line, okay, it says radians degrees. Since we're working in degrees, I want to change that to degrees. Okay, notice it changed my degrees up here, and that's going to make things a heck of a lot easier for us. So it's going to be important that you watch your mode of your calculator as you work through things. Okay, because these problems in chapter 9, I'll tell you in chapter 9 they generally like radians a lot more than anything. Chapter 10 kind of splits between radians and degrees as far as your answers go. And then when we get to chapter 11, we'll do a lot more degree work. Kind of like that's the layout of things. So, but definitely make sure that you pay attention to the mode of your calculator. Just be careful. Okay, so we're in degrees. So I'm going to hit second mode to quit. And then show you where some stuff is at. So right up here above the word apps is the blue word angle. If you hit second apps, look at that. There's the degree symbol. There's the minute symbol. And then down here, there's this DMS, which we're going to talk about. So these are going to be kind of important for us. So the the degree, the minute, the DMS. Notice you don't see any seconds up here. I'll show you where the seconds is. If you hit second and 0, which brings up what we call the catalog. If you scroll up, right there, there's the seconds. So your seconds is in the catalog. Okay? So show you some cool things that you can do. We can take and we can put in 18 degrees, 9 minutes in the calculator and have it convert straight to the decimal for us. Our calculator's that good. Okay? So if we come in here and we hit 18 second apps degrees, and then it was 9 minutes, right? Yeah. 9 second apps, scroll down to minutes, hit enter. There it is. There's that 18.15 we talked about. So go ahead and try putting this one into your calculator. The 74 degrees, 8 minutes, 14 seconds. And go. Okay. So you come over here, hit 74, second apps, degrees, 8, second apps for the minutes. And then I've shown you where the second is, so you hit 14, second 0 for the catalog. Scroll up, and there's the minutes. Hit enter one more time, and there's that beautiful decimal that we came up with. So you can use your calculator to help you out. Again, I showed you really what's going on. I think it's important that you understand how this is getting converted. This is what your calculator is doing in the background. So whether you use this or whether you use the calculator, it doesn't hurt my feelings. I'm always like, work smarter, not harder. So I would probably just use the calculator. The next one, well, let's go back the other direction. Let's convert this decimal degree into degrees, minutes, and seconds. So I've kind of already given you an idea of where this DMS is. So I'll talk about that here in a second. Let me show you the work that's really going behind this. So right here, you already have the degrees. Okay? What we need to do is we need to convert this 0.187 into minutes and seconds. Well, here's how this works. So the first thing you're going to figure out is the minutes. So we're going to take 0.187. Remember that we want to know how many minutes this is. Okay? So for 1 degree, because this is all in degrees right now, it takes 60 minutes. All right? So all we're going to do in the end is take 0.817 and multiply it by 60, and that will tell us how many minutes there are. So you go to your handy-dandy calculator, 187 times 60 gives us 49.02 minutes. So right here, all we're going to do is take the whole number, and that's going to represent our minutes. Okay? And then the next piece, well, right here, this is all in minutes now. We want to convert this to see how many seconds this is. So just like what we did a second ago, we're going to take that decimal, the 0.02, and we know that it takes 60 seconds for every minute. So that's what we're going to multiply by. We're going to take 0.02 times 60, and right there, that tells us that it is 1.2 seconds. So up here, they don't really want the 0.2, so really, generally, when it comes to the seconds, you just drop off the end piece. So it's 1 second. That's the piece that we grab. And there it is. That's really what's going on in the calculator. You take your decimal, multiply it by 60. That tells you the minutes. Take the minute decimal, multiply it by 60. That will tell you the seconds. Again, our calculator can do this. So if we come in here and put in the, what was that beginning number? 34. 34.817. And again, you hit second apps. You don't really need to do this because we're already in degrees, so your calculator knows this is in degrees. So if you want to put the degree symbol, you can, but you don't have to. And then go back into apps and then work with number 4 because this says convert to degrees, minutes, and seconds. So scroll down to number 4. And there it is. See, there's that number we came up with. And there's the 1.2. So again, we can just drop off the 0.2 because we don't really care about that. So there it is. You can let your calculator do all that for you. Okay? And again, like I said, we don't really have to have the degree symbol there. I can scroll up and grab that and scroll over here just to show you that as long as my calculator is in degrees, I don't have to have that. So if I just delete that out, there's the same answer. Okay? So some other things that you're going to be doing, a little bit of adding and subtracting with these. So we want to know what happens if we add degrees, minutes, and seconds. Okay. All this is just like combining like terms. Okay. Just like, excuse me, what you would do with normal adding and subtracting. Okay. So generally when I deal with adding and subtracting, I like to write them vertically because I like to have things lined up. Because this adding and subtracting is a lot like when you did adding and subtracting back in, middle school and elementary and all that. Okay? So all they want us to do is add. If we subtract, then we subtract. So you either add down or subtract down. Okay? Also, when you're doing adding and subtracting, once you get the adding and subtracting done, you're going to want to check your degrees and minutes. You're going to want to check your minutes and seconds, because if you're over 60 minutes, you need to add a degree. If you're over 60 seconds, you need to add a minute. So you need to double check that information and see if there's any it's like carrying the 10. Okay? So go ahead, pause the video, give this a shot. All right, 29 plus 46 gives us 75 minutes. So right there you can see that we are definitely over 60. We're going to be adding degrees over, but we'll do that here in a second. And then if you take 51 plus 32, that gives us 83 degrees. Now again, we're not done because this guy right here is over 60. So if I take 60 out of this, that becomes a new degree. So that makes us really at 84 degrees. And what's 75 minus 60? It's 15 minutes. So right there is the real answer. And you can have the calculator do this for you. There's nothing wrong with that. Okay? Your calculator can add degrees, minutes, and seconds and all that. Okay? So if you go to your calculator and you put in 51 second apps degrees, 29 second apps minutes, plus 32 second apps and degrees. Oops, too many twos. Delete one of those out. And 46 second apps minutes. Add it. There's the decimal answer. But again, you know how to turn this into degrees, minutes, and seconds. Hit second apps. Second apps, there we go. Go down to number 4. And there's the answer that we came up with. Of course, we didn't have any seconds, and that makes sense. So 84 degrees, 15 minutes. Cool? So the calculator can do the work too. I think doing it by hand is probably a little bit faster. There's a lot of button pushing there. But, you do you, boo. So over here, you got subtraction. Again, like I said, I like to line things up. 90 degrees minus 77 degrees, 51 minutes, 21 seconds. Okay? Go ahead and get this a shot. Please also know, hint, hint, you cannot have negative minutes and negative seconds. They don't exist. Go ahead, give this a shot, and go. Okay, so hopefully you realize that there are zeros here for the minutes and zeros for the seconds. And just like what you did in normal adding subtracting, whenever the top number was not large enough, you had to borrow. So in order to subtract down the seconds, I got to borrow from minutes. But wait a minute, there are no minutes. So that means I got to borrow from the degrees. And this is why we had that talk about how many seconds and minutes are what. Okay, so I'm going to borrow 1 degree. That's going to make this 89 degrees now. And if I borrow 1 degree, that makes this 60 minutes, because there is 60 minutes, or there are 60 minutes in 1 degree. Okay, and now I know these can subtract, but again, we got to borrow from the minutes to help us with the seconds. So I'm going to take 1 minute, which now makes this 59 minutes, and I'm going to come over here and give that to the seconds. So remember that there are 60 seconds in 1 minute. And now you can do the adding and subtracting. You can do, well, actually really just the subtracting. So all you got to do is just subtract down. 60 minus 21 gives you 39 seconds. 59 minus 51 gives us 8 minutes. And 89 minus 77 gives us 12 degrees. Okay? And there's your answer. Again, you could easily just go to the calculator and do this. I'm not going to do that, but, you can if you want. So there we go. There is converting degree decimals to degrees, minutes, and seconds, converting decimal or degrees, minutes, and seconds to decimals, adding, subtracting. You got some cool things that are now at your fingertips. So let's flip the script, and now let's talk about radians. Okay? The radian is an angle with the vertex at the center of a circle, and that intercepts an arc on the circle equal in the length of the radius. So the angle has a measure of 1 radian. Okay? So whenever this arc length right here, okay, that's your arc length. And your radius length here, or even on the other arc, the radius, whenever these two things are equal, you are creating radians. Okay? You are creating radians. So, that's really what a radian is. Okay? So let's go in here and let's talk about these kind of angle measures. All right? So the first thing that we want to do is, again, we're going to go back to those geometry aspects, and we want to find complementary and supplementary. Well, before we do this, let's make a couple of notes. Remember that complementary is 90 degrees. In radians, that is pi over 2. 90 degrees is pi over 2 in radians. Okay, you'll start to understand more about that pi over 2 soon enough, but just you're going to have to take my word for it. Supplementary, again, that's 180 degrees, or pi. So in radians, 180 degrees is pi. So again, just like what we did earlier, how we took 90 minus the angle measure, okay? And this one, it's not 90 because we're in radians. So all we're going to do is we're going to take pi over 2 minus 3 pi over 7. Okay? And down here, we're going to take pi minus 3 pi over 7. So what you're getting into is fraction work. I want you to understand, please do not do these fractions by hand. That's just silly. You need to have your calculator help you out with these. Okay? So all this should be done with the calculator in mind. And what's going to happen when we're dealing with this, because they want an exact answer. They want the answer in radians. Okay? So you can take, and what's going to happen is you're going to actually leave pi alone. Your answer is going to have pi in it. And what you're really dealing with is the fraction that's right here. This fraction, if I ignore the pi, is really 1/2. This is why I say you're doing fraction work. If I ignore the pi right here, this fraction really is 3/7. So what I'm going to go to my calculator and do is I'm going to put 1/2 minus 3/7. I can't put the pi in the calculator. Even though there is a pi button, if you put pi in, it's going to make it a decimal. And we don't want the decimal. We want the actual radian measure as a fraction. So what's going on in here is you're working with 1/2 minus 3/7. The pi just tags along for the ride, and it stays in the numerator. So I go to my calculator. If you don't know where your fraction key, here it is. This is your best friend, alpha y equals. That's your fraction key. And we're going to be working with number 1. So we're going to put in 1/2 minus alpha y equals 3/7. And we're going to hit enter, and there we go. There's our fraction. So over here, back in our notes, we can say 1 pi over 14. Or if you wanted to, you can call it pi over 14, because generally we don't write the 1 in the numerator. Okay? Both of those are solid answers. Again, it's just fraction work. Down here, if you look at this, again, our answer is going to have pi. in the numerator. But what's going on here, there is a number in front of pi, there's a 1. So what's really happening is you're taking 1 minus 3/7. And if you go into your calculator and type in the fractions, I trust that you can do that by now, hopefully, you get 4/7 pi. And there you go. That's what they're looking for. It's just a little bit of fraction work. Leave the pi alone and do not push pi on the calculator. I'll let you know when you need to push the pi on the calculator. Okay? So, a little bit of geometry coming right back at you right here. And it's the same as what we talked about earlier with complementary and supplementary. Except this is the complementary angle in radians. It's 90 degrees is pi over 2. This is the supplementary angle to 180. 180 degrees is pi. Okay? And just like before, we're going to talk about converting between degrees and radians and degrees. So right here, this is how this works. So when you convert degrees to radians, you take your degrees and you multiply it by pi over 180 degrees. Okay? So we use the relationship between supplementary and the radian angle of pi to help us convert. So when you want to convert from degrees to radians, take your degrees and multiply it by pi over 180. When you want to convert radians to degrees, take your radian measure and multiply by 180 degrees over pi. Okay? So that's what's going to do next. We're going to be converting from degrees to radians and radians to degrees. So go ahead and pause the video and give this a shot. Remember, leave the pi alone when you deal with this stuff, especially when it comes to radians. When it comes to degrees, the pi should cancel out. And go. All right. So right over here, we're going to take 45 degrees, and we're going to multiply that by pi over 180. So in other words, really what's going on is you're just taking 45 times 1 over 180. That's really what's going on behind the scenes. Okay? So if you take 45 times 1 over 180, you end up with, 1/4. But again, the pi stays in the numerator. So 1 pi over 4 is fine, or you can call it pi over 4. Both of those are valid answers. Okay? Most of the time here, probably when I get to the next section, I'm going to be dropping the 1 in front of the pi. Okay? And just call it pi fourths. All right, over here, 9 pi over 4. We're going to multiply that by 180 degrees. And this should be in degrees. Degrees. I'm very, you could say, particular about my labels. I think they're very, very important. And then pi. If you also notice, radians, they don't have a label. We don't put rad after it. I put that over here so you know that this means that we're talking about a radian number. Okay? So radians does not actually have a label. So unless you see degrees, your number's in radians. So over here, like I said, the pi's, one's on top, one's on bottom. We know that that's just going to cancel out. So really what's going on, what you have here, is 9 over 4 times 180 degrees. That's really what's going on. So if you just go to your handy dandy calculator, you type in your fraction, multiply it by 180, you get 405 degrees. Some cool things. Your calculator can actually convert all of these. It's better to have your calculator convert radians to degrees. Because when you convert degrees to radians, it's going to come out as a decimal. And they don't want the decimal answer. They want this answer of pi over 4. Okay? But let me show you how your calculator convert radians, to degrees. Make sure your mode is in degrees. And then all you're going to do, put in the fraction. So we had 9. Now you actually put in the pi over 4. And then go into second apps to your angles. This R right there means radians. So if you scroll down to that R, you are telling your calculator that this is a radian measure. All you got to do now, enter. There's the degrees. So your calculator is really good about converting radians to degrees. Okay? You also could have actually come back here, and I have no problem with this. If you don't like working with radians, you could have done these problems in degrees. We could have converted 3 pi over 7 into degrees, and then taken 90 minus that, and then converted that answer back into radians. So if you're in radians, you can always convert it to degrees, work with it in that, and then just make sure that you adjust your answer in the end if it wants it in degrees. You can always switch between these two. I've just given you the way to do that. Okay? So, now that you know how to convert, try this conversion. So we are in degrees and minutes. I want you to convert this into radians. Go. Okay. So, the first thing you're going to have to do, you need to convert this into the decimal version of this, because we have no ratios that tell us how to work with minutes into radians. Okay? So, first thing is, we need to take 30 divided by 60. So if you take 30 divided by 60, you get 0.5. So now we know that we're working with 115.5 degrees. Now that we have this, now we can convert this into radians, just like what we did a moment ago. So we're just going to take this and multiply it by pi over 180. Okay? Degrees. Or in other words, we're going to take 115.5 degrees times 1 over 180 degrees. That's really what's going on. So you just go to your calculator. You know how to put in fractions. So 115.5 times 1 over 80. You get, and then you're going to want to turn this. All right, so let's do this in the calculator so I can help you out with this. Show you some other cool features. 115.5 times alpha y equals 1 over 180. Oops, not 1,800. That's just silly. And there it is. So, your calculator kicked out a decimal. That's no good. We actually need the radian measure. Well, go back to that alpha y equals. Right down here at the bottom, number 4, fraction to decimal, decimal to fraction. Scroll down to it. Hit enter. Hit enter. And there is our radian measure. Just don't forget to put pi in the top. So 77 over 120. So 77 pi over 120. There's the radian measure. See, not too bad, but definitely using a lot of those skills that we already know. So know that if you need to convert degrees, minutes, and seconds into radians, you got to turn it into its decimal first, and then multiply by what you know how to do. Okay? All right, standard position. Let me tell you what standard position is. And I've kind of already described it to you. Standard position, let's see here, what do I got under here? Okay. So I kind of let's just spoil it for you. So it says the vertex is at the origin, okay? And the initial side is drawn along the positive side of the x-axis. So my initial side, just like what I talked to you at the beginning of this video. So there's my initial side. Standard position means that then somewhere out here is that terminal ray. Okay? So maybe it's there. Or maybe it's along the y-axis. Or maybe it's along the negative side of the x-axis. Or maybe it's out here in the third quadrant. And again, in standard position, we are generally rotating Counterclockwise for a positive angle. And I don't think I told you what that angle symbol meant. That angle symbol is the Greek letter theta. So you will see lots of Greek letters in this. So that, whoops, knocked off my headphones. That Greek letter represents theta. And then if you go in a counterclockwise direction, remember that's a negative theta, a negative angle. So standard position. That's what it means. Your vertex is the origin. You got the initial side on the positive side of the x-axis, and then your terminal vertex is somewhere out here. And you have to look at the angle to know whether you rotated a positive direction or a negative direction. Okay, let me see what's next real quick. Yeah. So let me tell you, in here, in quadrant 1, just to kind of give you some information, this is where you have 0 degrees and 90 degrees, or 0 and pi over 2 radians. In quadrant 2, this is where you have 90 degrees to 180 degrees, or pi over 2 to pi. Quadrant 3, this is where you have 180 degrees to 270 degrees, or pi to 3 pi over 2. And then last but not least, quadrant 4, you have 270 degrees to 360 degrees, or 3 pi over 2 in radians to 2 pi. There you go. Just to kind of give you some idea of where certain angles go. And again, when I deal with radians, I think about it as a fraction. I kind of ignore the pi. So if I'm looking at this is from 0 to a half. So any fraction that follows in 0 and a half, I'm in quadrant 1. Any fraction that is from a half to 1, I'm in quadrant 2. Like 3/4 is in quadrant 2. Okay? Any fraction from 1 to 3.5, or in other words, or 3 halves, so 1 to 3 halves, or 1.5, 1.5, I'm in quadrant 3. And anything from 1.5, or 3 halves, to 2 is in quadrant 4. Okay? So let's talk about coterminal. Coterminal is so very important for us. You will see coterminal a lot, and we need coterminal. Okay, I need you to understand this. The best kind of analogy I can give you for coterminal is think about the movie Elf. Okay, when he just enters New York City and he goes to that building with the rotating door. Okay, he goes in that rotating door and spins around and around and around and around, and then comes right back out the same place he started. That's coterminal. Okay, when every angle has infinite amount of coterminal angles. You just keep spinning around 360 degrees, one direction, either clockwise or counterclockwise, and you're making coterminal angles from that angle. Okay? So that idea of Elf spinning around in that rotating door over and over and over again, and then coming right back out onto the New York streets, that's coterminal, because he's right back where he started. Okay, he just went around 360 degrees so many times. So coterminal is exactly what I just said. Angles that have the same initial side and terminal side. In other words, what's going on is we are adding and subtracting 360 each time, whatever your angle is. So whether you're in degrees or radians, so degrees, keep putting 0 there. You're adding or subtracting 360 degrees. Or if you're in radians, you're going to add or subtract 2 pi. That's how you make coterminal angles. Now, we do have two specific kind of coterminal angles. is called the least positive coterminal and the greatest negative coterminal angle. So what we mean by those is, depending on your angle, to be least positive, that means you need to be between 0 degrees and 360 degrees. Okay? Anything that is bigger than 360 degrees, you want to subtract 360 to get the least positive until you're within this range. Okay? The greatest negative is between 0 degrees and negative 360 degrees. Or in other words, what I'm talking about here, 2 pi. And down here, negative 2 pi. Okay, you're going to see examples of this here in just a second. The book also does kind of a poor job of distinguishing between these two, but I wanted to know the least positive coterminal angle is any angle that has a measure between 0 and 360 degrees. That is the least positive. The greatest negative coterminal angle is any angle that has a measure between 0 degrees and negative 360 degrees, or negative 2 pi. Okay? So right here, I want to talk about the least positive, the greatest negative, and then writing an expression for all possible coterminal angles. Okay? So, right now, if I want the least positive coterminal angle, okay, I'm just abbreviating it so that way I don't have to write out all that stuff. So, if I look at this, my angle is 45 degrees. Is 45 degrees between 0 and 360 degrees? Absolutely. So technically, this is the least positive coterminal angle. Now, what the book is going to make you do, and I despise this, they need to fix their directions. It's going to ask for the least positive. This is what my math lab will make you do. So let me give you the version of this. So this is the My Math Lab. So it's going to give you this angle, but it says this is not the least positive coterminal angle. So to get the least positive coterminal angle for this, they want you to add 360. So if the angle they give you really is the least positive, in My Math Lab, they actually want you to add 360 degrees of this, or 2 pi. Okay? So it's really weird, because if I take 45 plus 360 degrees, that's 405 degrees. So if this is a coterminal angle. So if I entered that rotating door in ELF at 45 degrees and rotated 360 degrees, I would have technically rotated 405 degrees total. Okay? But I would come out at the same angle that I came in at on the door. That's what it means to be coterminal. The angles look the exact same. Let me see if I got an angle picture. So if this is 45 degrees, 105 degree rotation would be, there's the 45, and then now I rotate all the way around 360. So that black circle there, that's 405 degrees. And it's the same angle. It looks the same. I still have that same red line, that same blue dot, and that same purple ray right there. That's a coterminal angle. Okay? You just end up right back at the same spot. The angle doesn't look any different. You just kept rotating around and around and around and around. So again, in My Math Lab, if this is already the least positive coterminal angle, you have to add 360 to it to get the answer that My Math Lab wants. So that's what they're really looking for. But this really is the least positive coterminal angle. If I'm looking for the greatest negative, I don't know why I drew an M, coterminal angle. Well, obviously, this is not the greatest negative. So in order to get the greatest negative, all I'm going to do is take my 45 degrees here and subtract 360 from it. Okay? So 45 minus 360 gives us negative 315 degrees. So if I kind of go back to that picture that I had a second ago, if I take this, let's see here, what color do I not have? Yeah, let's go with blue. Okay, and I rotated counterclockwise, negative 315 degrees, I would end up right back at that same angle. So this blue circle represents that negative 315 degree rotation clockwise. Okay, so that would be the greatest negative because this number is between 0 and negative 360 degrees. And again, just like before, if they give you a negative number, say this was negative 45, then that technically is the greatest negative coterminal angle, but my math lab would say, okay, come in here and please subtract 360 from that. And that's what the greatest negative coterminal angle would be. And that's so incorrect. So, if it was a negative 45, then you would have negative 405 degrees. That would be what they want as the greatest negative. Okay? So, yeah, it looks like that. And they also sometimes will give you radian measures for this. So you know how to deal with radian measures. You either be adding 2 pi or subtracting 2 pi. Oh, I didn't finish this question. It says write an expression. So an expression. We want it to figure out all possible coterminal angles. Okay, no worries. So again, I actually kind of gave you this expression in our notes right over here. Right here, this is the expression. Okay? All you have to do is put in the angle that you're dealing with. Because if we keep adding or subtracting 360, that's always going to be coterminal. So our expression is 45 degrees plus or minus 360 degrees. So if I take 45 and just keep adding 360, there's all my positive coterminal angles. If I take 45 and keep subtracting 360, there's all my negative coterminal angles. Okay? One other little piece of information for this. If the angle they give you is really, really big, like, 1,000. Let's take this example. What color haven't I used? I used all of them. Let's just say they gave you the example 1,485 degrees, and they wanted you to find the least positive coterminal angle. Obviously, this angle is way, way big, and that's definitely not between 0 and 360. So all you do to get the least positive, keep subtracting 360 until you get there. Okay? And so if you take 1,485 and subtract 360 4 times, you'll end up at the least positive coterminal angle. So sometimes they're going to give you really, really large angles, and to find that coterminal angle that we're looking for, sometimes you have to keep adding or subtracting 360 until you get between the designated range. Okay? I also messed this up. Yes, it is add or subtract 360, but it's actually 360 degrees n, or put the n in front of n 360 degrees, because just like what we did over here, we don't know how many times we want to spin around. If I just had the 360 there, then all we would do is be adding at once and subtracting at once. I'm sorry, I didn't mean to mess that up. But it's an n with it because we don't know how many times we want to spin around that, spin around in that rotational door, Maybe we want to go 5 times, maybe we want to go 4 times. So that's what this represents, how many times we're going to spin around 360. So don't forget the n. That's important. Okay? All right. We're getting there. We're almost to the end. So quadrantal angles are pretty easy to know about. They are the angles in standard position, and the terminal side is along the x-axis or y-axis. So our quadrantal angles are whenever we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, or obviously any coterminal angles for those. If we're in radians, then that would be 0, pi over 2, pi, 3 pi over 2, 2 pi. So those are the quadrantal angles. Because their terminal sides are along the axes. Okay? So kind of going back, show you, highlight some. So this purple ray right here, that's terminal, that's a quadrantal angle with the red. Okay? Because it's 90 degrees. This purple angle right there, that's quadrantal because that is 180 degrees. Okay? This would be a quadrantal angle if I had a purple line right here. Let's just go ahead and draw that in. That's a quadrantal angle. And then if both the terminal and initial side are right there, that's quadrantal. Okay? That's all quadrantal means. They are on the axes. Okay? So, the last part that you'll have in here is just some arc length type problems. So, we've got some easy formulas right here for you. So, arc length is S equals theta r. So I know in geometry you learned a whole bunch of ways to find arc length. Well, now that we're in trig, we can kind of speed things up for you and give you some faster formulas. That's going to be kind of cool thing about trig is that you're going to get some new formulas for some things. Like I'm going to give you some new formulas for the area of a triangle that exists because of trig, and it makes, finding the area of a triangle really, really quick. And just like here, you can find the arc length really, really quick. So S equals theta r. So let me tell you what those mean. S is the arc length. Theta is the measure of the central angle, and it's in radians. Super important. When we deal with arc length, we are dealing with radians. So that means that they give you something in degrees, you must convert it to radians. And r represents the radius. So what you'll see in your assignment, they'll give you a circle like this, and it says, find the arc length. All you got to do is plug and chug. Now again, notice that this angle is in degrees. So you need to convert that to radians. So in order to convert that to radians, we're going to multiply by pi over 180 degrees. Okay? So you go to your handy dandy calculator and you multiply everything out, and you find out that you get 4 pi over 5 radians. Okay? So now that you know the radians, this guy down here is the radius, you can find the arc length. Go ahead, do that for me. Pause the video. Go. Okay. So, S is equal to our arc length, which is 4 pi over 5, times our radius, which is 18.2. For this problem, they do not want the exact answer. They want you to round. So when you go into your calculator, you will actually plug in pi for this. Okay? Plug in the pi for this. Because the calculator, they want the actual arc length without pi. Okay? So you go to your calculator. Alpha y equals 4 second caret key. There's your pi over 5. And we're going to multiply that by, was it 18.2, right? Yeah. 18.2. And you'll round accordingly. Okay? So you read the fine print. Since this is 18.2, I think they're probably going to have you round to the 10th. So we would have 45.7 centimeters as the answer. And there's the arc length. Cool. Yeah, that's what your assignment's going to be like. Some other things that you're going to find out is that we can actually talk about rotating a wheel. Okay? Some other cool things. So they want to know through how many degrees to the nearest tenth, there's that rounding, will the larger wheel rotate if the smaller one rotates 60 degrees? Go ahead, pause the video, give this one a shot. And I believe this is the end of everything. Oh, nope, we got a sector. So we'll talk about the sector here in a second. So go ahead, pause the video, and give this one a shot. Go! Okay. Now, what I need you to understand is, however far this bottom wheel rotates, the big wheel has to rotate that same amount. Okay, because they're touching each other. This length has to be the same amount as that length. So I need you to understand that. Because the first thing you have to do is you have to find the arc length of the small wheel. Because the arc length of the small wheel will also equal the arc length of the big wheel. Okay? That's important to know. So we already know how to find arc length. S equals theta r. And we have the r. We know what theta is. It's 60 degrees. But again, you got to change 60 into radians. So we multiply by pi over 180 degrees. And when we multiply that, we get pi thirds, or 1 pi thirds. Okay? So all we got to do is plug in. S is equal to pi over 3. Your R is 5.23. Okay? So we go to our calculator. Come on, calculator. There we go. Alpha y equals second pi. Put it over 3. And 5.23, I think it was. Yeah. So hit enter. And we need this number. Okay? We need all of it. No rounding yet. Even though the directions say to the nearest tenth, but that's for the end. Okay? So no rounding yet. So we've got 5.47. See if I can read it from here. 47684 6843193. Now, that's how far the little wheel rotated, which also means that's how far the big wheel rotated. Okay? So all we need to do now is run the arc length formula for the big wheel and figure out what theta is, because we want to know how far it rotates. That's not that hard. So we know that we've got 5.476843193 equal to theta, and your R is 8.16. So how do we get theta by itself? Divide by 8.16, because it's like the variable x. That's all it is. Theta is just a variable. 8.16. So I'm going to go to my calculator. I'm going to scroll up, grab that number, divide by 8.16. And there we go. So there's our theta. But remember, this is in radians. We want to be in degrees. So we got 0.671181. So theta is equal to 0.671181. 7638. 7638. And again, this is radians. So all we have to do is convert this into degrees by taking and multiplying this by 180 degrees over pi. And yes, we will use pi because we're going to have to round to the nearest tenth. So you see why I had to keep this accurate, because if we would have rounded here, then we would have rounded again, and now we're going to round again for a third time in the end. You can't do that. You have to be accurate. So you got to keep track of those numbers. So we're going to take that number times. So that's what the A and S means. Take that previous answer, or I could have scrolled back up like I did a moment ago and grab it, times alpha y equals 180, and then second pi. You have to use pi on this. And there's how many degrees that is. 38, and it said round to the nearest tenth, so 38.5 degrees. And there we go. Yep, you just had to use arc length twice. Find the small arc length first, and then that's how much the big wheel has to turn, and then you can find the angle. You got this. So again, just like what we kind of talked about, there were geometry formulas for arc length. There were geometry formulas for sector. Arc length, if I didn't kind of describe it to you, think about arc length as like the crust of a pizza. It's the outside rim of a pizza. That's what arc length is really about. Okay? So arc length, if I kind of draw, actually I can grab a circle right here. So that way I can kind of give you a visual. Arc length would be the outside here. So that purple is the arc length. When we talk about a sector, so a sector for us, here's the formula. And again, A means the sector, R is the same radius, theta is still in radians, it's our central angle. But when we talk about the sector here, thinking about like a pizza, okay, that's all the ooey gooey goodness inside a slice of pizza where all the toppings exist. That's what a sector is. Okay? So, again, you'll have a question where it says, find the area of a sector. Do I have one after that one? Nope. So there we go. This is it. So find the area of the sector. Go ahead, pause this video, and find the area of that sector. Go. Okay, hopefully you didn't say like, Mr. Armstrong, the area is already there, because actually, no, the area is not there. What you're looking at here, this number right out here, that's actually the arc length. So this big red line is actually 2 pi. So you actually need to find theta first. Once we know what theta is, then we can find the area. So we have to run S equals theta R, figure out theta first, then we'll be able to come over here and run area equal to 1/2 R squared theta. Okay? So we know that S is 2 pi, that's the arc length, equal to theta R. Okay? Oh, sorry, and we know what R is. R was 10. The cool thing about this, notice our arc length is in radians. That's awesome because we don't have to worry about converting to degrees on this. So hopefully you didn't do any converting to degrees. Divide by 10, divide by 10. We now know that theta is equal to, and if you reduce the fraction 2/10, pi over 5. So all we got to do now is take this information and plug it into our area formula and round accordingly if it tells you to round or keep it exact. So R is 10, and we're going to square that. And then our theta is pi over 5. Okay? So if it wants you to round, then I would just go and plug this all into my calculator. If it wants your answer to be exact, because it kind of seems like that since this is pretty exact, there's no decimals up here, then I would treat this as the fractions they are. This is 1/2 10 squared times 1/5. And I would put that into my calculator, and then in the end answer, I would have pi in the numerator. Okay? So if you're going for an exact answer, you just leave pi alone. Let it be in the numerator, and just multiply all of your fractions. So let's get that real quick. So we've got alpha y equals 1/2 10. oops, too many degrees squared, and then alpha y equals 1/5. So our exact number is 10. So that means we don't actually have to have the line underneath it. An exact answer, the sector area is 10 pi. And of course, they didn't give us a label up here, so we would call that units squared because it is area. Okay? So there's the exact answer. If they wanted it rounded, so then you just take 10 times pi and round according to whatever they tell you. And that right there wraps up 9-1. Lots of basic ideas. Don't forget about coterminal. Coterminal is going to be very, very important for us. And then don't forget how to convert between things. You got this. Thanks for joining me.